Oh no, it's a particle problem.
This is my second go at this video because the other one was way too long. So I'm going to try to speed this up. So this is a particle problem traveling on an x-axis. This is our velocity function given only when t is between 0 and 2 pi. Okay, so here's what's going on here. We have a particle going back and forth on a horizontal line. Okay, so we have going right or we're going left. The particle is, it's going this way, then it goes that way, and then it goes that way even farther. Okay, so anyways, first question says, at what values of t is the particle moving to the right? So what you want to do is you want to find out where the velocity is positive. And so I made a plus minus graph for this. Really simply, you just got to take this dude and set it equal to 0. Once you set it equal to 0, you can find your answers t equals pi over 6 and 5 pi over 6. Quick review. Sine right now is 1/2. And 1/2 is positive above the x-axis. Sine is the y values in each of our coordinates around the unit circle. Okay, so pi over 6 and 5 pi over 6 both give you a y value of 1/2. Therefore, those are your answers. Pi over 6 and 5 pi over 6. Okay, so when I plug those in, or not plug them in, but if I use those to make my plus minus graph to figure out where this function is positive, where this function is negative, this is where I would put them. And then you would pick tester points. Now, a tester point doesn't quite work well right here between 0 and pi over 6 because, frankly, I don't know what the sign is of pi over 12. And so what I did instead is I graphed it. Graphing it's not too hard because if I were to just graph sine of t, you guys know that looks like this, right? Now, because it says negative sine of t, I know that it's flipped, so it's going to be like this. And this positive 1/2, which can be put over here, so it's negative sine of t plus 1/2, then the whole thing is going to be shifted up 1/2, and so this is what we got going on here. We have a little spot that's above the x-axis. This spot will be below the x-axis, and this spot will be above the x-axis. And guess what these two x-intercepts are? Yeah, you guessed it. We already found those guys, and so I know that we're plus, minus, plus, and so that's how I got my signs right there. Now, this doesn't count as an answer, so I'm going to translate this into interval notation. This is interval notation. This right here is called inequality notation. Either one works. I'm just going to write it like this. So this is the first part. That's the last part. That's your answer for the first one. That's where the particle is moving to the right. Next, now we're told the particle is starting at x equals 3. Now, if we're starting at x equals 3 and we want to know the final position of the particle, we have to know how much we move to the right and then how much we move to the left and then how much we move to the right again. Okay, and I know we're going right, left, right because of this. Right, left, right. Okay, so essentially what we have to do, this is the total of this area is the part where we moved right first. The total of this area is the part where we moved left. And the total of this area is the part where we moved to the right again. We just need to add all these together. Now, we could find each interval separately, or we could just find the whole interval all together. Because if I just went straight from 0 to 2 pi, it'll add all of those automatically for us. So that's what I'm going to do. And notice I have a plus 3 right here. You can write it right there, or you can put the plus 3 in the end. I like doing it right from the beginning so I don't forget. Because usually, once you do all this stuff, you're like, yay, my answer! And then you'll just circle pi and you'll be wrong. So that'll be sad. Don't do that. I write it first. So the first thing I gotta do is take the antiderivative of this so I can get rid of this integral and this dt. This is what I get. I get 1/2 t plus cosine t. And yes, the sign changed to plus. And then I write this. I put 2 pi and 0 next to this vertical line to remind myself I'm plugging in 2 pi minus, then plugging in 0. So that's what I did right here. Plugged in 2 pi minus, plugged in 0. After all this work, all these things cancel out and what have you, I get this as my answer. So this is my final position, and I'm going to leave it just like that. Okay, next one, total distance. Now this is kind of the same. Before we were finding the distance, we went to the right, then to the left, then to the right to find our final resting place. But this time we want the total distance traveled. So essentially, guys, what we're doing is we're taking the absolute value of the velocity function. We don't want to add a negative distance. We want to count it. And so we got to make it go above the x-axis. So to do that, we just say absolute value. Now in your calculator, you can just throw it in there and it'll give you the answer right away. So nice. Now, since we have to do it longhand, we have to break up the intervals. So this interval is already positive. So we're just going to leave this one as is. The next interval where we're going negative, we can't leave that one as is. So I chose to put a negative in front of it. That just means I'm going to change the sign after I do all this work. I'm going to change the sign when I'm done with it. Or what you can do instead of that is you can switch these two. And if you switch those two, the sign will change automatically. And then this one is our last one. It looks like, okay, yeah, I haven't taken the antiderivative yet because we still have the integrand. We still have the interval signs. Oh, yeah, so this is what I did next. This is the first one. And then the second one is right here. And then the last one is over here. And so all I'm doing is I'm taking the antiderivative that I found earlier and I'm finding it for each of my intervals. The only tricky one is this one right here. You have to be careful because you still have a negative out there. So after you find, the first one and then you plug in the second one, you got to make sure your signs are correct and you got to distribute that negative. Hopefully I did all my little arithmetic correctly here. I don't really want to go through each one, but let me know if I get it wrong. This is what I think it is. It's 2 rad 3 plus pi. A couple of them are magical and they cancel each other out. Love it. Next one, last one. We have to find if the speed is increasing or decreasing. So that's speeding up or speeding down. Okay, justifying your answers. Now, these are notes, okay? It's okay to write notes on your answer, but this is for you guys. When the velocity and the acceleration are opposite signs, that was a bad A. When velocity and acceleration are opposite signs, you would be slowing down, okay? Because remember, this is the speed and direction, and this is the acceleration. That is telling you how the velocity is changing. So in this one, we're going negative, and we're changing more negative, and so therefore, we would be speeding up. Same thing with the positive, okay? So first, I know that velocity at pi over 4 is less than 0. I know that from earlier. I have it right here, okay? Pi over 4 would be between these two dudes, and we know that we're negative the whole time there. So velocity is negative. That one's done. Next, I have to find acceleration. So take the derivative of the velocity function, and then plug in your pi over 4. It looks like I get a negative, so acceleration is less than 0. Therefore, the particle speed is increasing. All this counts for your justification, and you're done.